Hey there, space enthusiasts, science lovers, and curious minds. Welcome back to FactSpire. Or if you're new here, buckle up, because today we're diving into one of the wildest mysteries of the universe, dark matter. This isn't just some obscure cosmic footnote. It's the invisible glue holding galaxies together, the shadowy riddle that's baffled scientists for nearly a century, and a topic so mind-bending, it'll make you question everything you thought you knew about reality. We're not just scratching the surface either. This is a deep dive, 200 words of pure, unfiltered fascination, packed with little-known facts, jaw-dropping science, historical twists, and even a sprinkle of human psychology to keep you hooked. So, grab a snack, get comfy, and let's unravel the enigma of dark matter together. Trust me, by the end of this, you'll see the universe, and maybe even yourself, in a whole new light. Let's kick things off with the basics, because even the starting point here is wild. Dark matter isn't something you can see, touch, or scoop up in a jar. It doesn't glow like stars, reflect light like planets, or even flicker like a distant supernova. It's completely invisible, not just to our eyes, but to every telescope, camera, and detector we've ever built. So, how do we even know it's there? Well, it all comes down to gravity. Picture this. Galaxies spin way faster than they should. Based on the stuff we can see, stars, gas, dust, they ought to fly apart like a cosmic frisbee gone rogue. But they don't. Something unseen is holding them together, tugging on them with enough gravitational oomph to keep the whole show running. Scientists call this invisible puppeteer dark matter. And here's the kicker. It makes up about 27% of all the mass and energy in the universe. That's 5 times more than the normal matter, the atoms that build stars, planets, and even you and me. Wrap your head around that for a sec. The stuff we think of as the universe is just a tiny fraction of what's really out there. Now, you might be wondering, if we can't see it, how do we figure this out? The story starts way back in the 1930s with a Swiss astronomer named Fritz Zwicky. He was studying the Coma Cluster, this massive group of galaxies about 321 million light-years away. Zwicky noticed something bizarre. These galaxies were zipping around at speeds that didn't add up. Based on their visible mass, they should have scattered like leaves in a storm, but they stayed clumped together. He crunched the numbers and realized there had to be way more mass than what his telescopes could spot, about 400 times more by his early estimates. He called it Dunkle Materie, German for dark matter, and suggested it was some hidden stuff exerting extra gravity. At the time, most scientists shrugged it off. Zwicky wasn't exactly a people person. He once called his colleagues spherical bastards, meaning they were jerks from every angle. So his idea didn't catch fire right away. But he planted a seed, and decades later, that seed would grow into one of the biggest breakthroughs in cosmology. Fast forward to the 1970s, and enter Vera Rubin, an American astronomer who'd become dark matter's unsung hero. Rubin was obsessed with how galaxies rotate, and she started measuring the speeds of stars at different distances from their centers. She expected the outer stars to move slower than the inner ones. Newton's laws say gravity weakens with distance, so less pull, less speed, right? Wrong. She found that stars at the edges were whipping around just as fast as those near the core, sometimes even faster. It was like watching a merry-go-round where the horses on the outside somehow keep pace with the ones in the middle. Rubin's data screamed that something massive and invisible was out there, boosting the gravity across entire galaxies. Her work on these rotation curves didn't just hint at dark matter, it proved it was real. And it wasn't some tiny side effect. By the 1980s, her findings had flipped the script and the scientific community couldn't ignore it anymore. Rubin never got a Nobel Prize, which still riles up a lot of folks, but her legacy is etched in every galaxy we study today. So what is dark matter? That's the million-dollar question, or maybe the trillion-galaxy question. Here's where it gets trippy. We don't actually know. Not for sure, anyway. Scientists have ruled out a lot of suspects. It's not regular matter gone dark like rogue planets or dead stars, because those would still emit or reflect some kind of radiation we could detect. It's not black holes either, at least not the usual ones, since they'd leave other telltale signs like gravitational lensing flares. The leading theory says dark matter is made of particles we've never seen, stuff that doesn't interact with light or normal matter except through gravity. Think of it like a ghost at a party. It's there, it's affecting the vibe, but it won't dance with anyone or show up in the photos. One popular candidate is the WIMP, weakly interacting massive particle. These hypothetical heavyweights could be drifting through space, through you right now, barely brushing against anything. Billions might pass through your body every second, and you'd never feel a thing. That's how weak their interactions are, just enough to tug on gravity, nothing more. let's zoom out a bit and talk about how dark matter shapes the universe, because this is where it gets cosmic scale bananas. Without dark matter, galaxies wouldn't even exist. Rewind to the Big Bang, about 13.8 billion years ago. The universe starts as this hot, dense soup of particles, expanding fast. Normal matter, protons, neutrons, electrons, is buzzing around, but it's too scattered and jittery to clump into stars or galaxies on its own. Enter dark matter. Because it doesn't emit or absorb light, it cools faster than regular matter, forming invisible scaffolds, gravitational nets, that pull normal matter together. Over millions of years, these nets grow into filaments, walls, and clusters, like a cosmic spiderweb. Gas and dust fall into these dark matter traps, collapsing into the first stars, then galaxies, then sprawling networks like the Virgo supercluster we call home. Simulations without dark matter? They spit out a universe that's just a bland, empty haze. With it, you get the dazzling, structured cosmos we see today. It's like dark matter is the architect and normal matter's the paint. Now, here's a wild fact that ties into nature. Dark matter might have saved Earth from extinction. Picture the Milky Way as a spinning disk, with our solar system bobbing up and down through it every 64 million years or so. That timing lines up eerily with mass extinction events like the one that smote the dinosaurs 66 million years ago. Some scientists think dark matter could be denser in the galaxy's plane, and when we pass through, it might nudge comets out of the Oort cloud, sending them crashing toward Earth. One study from a few years back suggested a dark matter disk, a thin, concentrated layer, could amplify this effect. It's not proven, but imagine that, an invisible cosmic hand indirectly sculpting life's story on our planet. It's a reminder that dark matter isn't just out there. It might have shaped us in ways we're only starting to guess. Let's shift gears to technology, because humans aren't sitting idly by while dark matter plays hide and seek. We've built some insane machines to catch it. Take the Large Underground Xenon Experiment, or LUX, buried a mile deep in a South Dakota gold mine. Why underground? To shield it from cosmic rays and other noise that'd drown out dark matter's faint whispers. LUX uses a tank of liquid xenon, chilled to minus 100 degrees Celsius, waiting for a WIMP to bump into a xenon atom and spark a tiny flash of light. Scientists watch for years, hoping for that 1 in a gillion collision. So far, nada. But the hunt's not over. There's also the Large Hadron Collider, that 27-kilometer ring under Switzerland and France, smashing particles at near-light speed. It's not just about the Higgs boson. Physicists hope to create dark matter particles in those collisions, a long shot that could crack the case. And don't sleep on the Alpha Magnetic Spectrometer, bolted to the International Space Station since 2011, sniffing cosmic rays for hints of dark matter annihilation, when two dark matter particles crash and zap into energy. These tools are humanity's high-tech nets, cast wide into the cosmic dark. Here's a historical twist that'll blow your mind. Dark matter might have been spotted way earlier than Zwicky, but we missed it. Back in the 1840s, a French astronomer named Urbain Le Verrier noticed Uranus wobbling in its orbit, something Newton's gravity couldn't explain with the known planets. He predicted an unseen world, Neptune, tugging it along, and bam! Neptune was found right where he said. But fast forward to the 1920s, and astronomers saw similar wiggles in Mercury's orbit. They guessed another planet, Vulcan, lurked near the Sun. Spoiler, Vulcan wasn't there. Einstein's general relativity fixed Mercury's dance by curving space-time, no extra planet needed. Thing is, those early galaxy quirks Zwicky caught, they could have been dark matter's first hello if anyone had thought to look beyond normal stuff. History's funny like that. Sometimes the clues are staring at us, but we're too stuck in our old ways to see them. Let's get psychological for a sec, because dark matter messes with our heads in more ways than one. Humans hate the unknown. It's baked into us. Evolutionary psych says we're wired to spot patterns, predict dangers, control our world. Dark matter flips that on its head. It's 27% of everything, yet we can't touch it, see it, or even define it. That uncertainty gnaws at us, sparking a mix of awe and frustration. Studies show people react to cosmic mysteries like this with what's called existential curiosity, a drive to explore that's equal parts thrill and unease. It's why dark matter headlines grab us, why we binge videos like this one. It's not just science, it's a mirror to our psyche, pushing us to wrestle with the infinite. Ever felt that shiver thinking about the universe? That's dark matter tugging at your brain too. Back to space, because dark matter's got some galactic drama up its sleeve. Ever heard of the Bullet Cluster? It's this pair of galaxy clusters 3.8 billion light-years away that smashed into each other 100 million years ago. When they collided, normal matter gas, stars, slammed together, heating up and glowing in X-rays. But the dark matter? It sailed right through, untouched, mapped by how it bent light behind it. A trick called gravitational lensing. This was a slam dunk for dark matter's existence, showing it's not just some fudge factor, but a real, separate player. And get this, some galaxies, like Dragonfly 44, are 99.99% dark matter, with barely any stars to light them up. They're ghost galaxies, floating out there, barely whispering their presence. It's like the universe has a shadow cast we're only now learning to read. Science isn't done throwing curveballs, though. What if dark matter isn't particles at all? Some rebels, like physicist Mortebe Milgrom, say we've got gravity wrong. His idea, MOND, or modified Newtonian dynamics, tweaks Newton's laws at super low accelerations, like in galaxy outskirts, to explain those fast-spinning stars without dark matter. It's a long shot, and it struggles with stuff like the bullet cluster, but it's got fans who love its simplicity. No invisible stuff, just a new rulebook. Most physicists stick with dark matter, though, because MOND can't match the cosmic web or the universe's early echoes, like the cosmic microwave background radiation from the Big Bang that dark matter helps shape. Still, the debate keeps things spicy, reminding us science isn't settled, it's a living, breathing hunt. Let's talk nature again, because dark matter might connect to life in ways we can't fathom. Some theorists, like physicist Lisa Randall, wonder if dark matter comes in flavors, not just one type. Maybe there's a dark sector with its own particles, forces, even ecosystems, invisible to us but bustling in parallel. Imagine dark matter planets, dark stars, dark life, beings that don't need light or heat like we do, thriving on gravity or exotic energy. It's pure speculation, but it flips the script. What if we're the weirdos, and the dark universe is the norm? On Earth, we've found life in pitch-black ocean trenches, powered by chemical soups, not sunlight. Could dark matter host something similar on a cosmic scale? It's a stretch, but it's the kind of stretch that keeps you up at night, staring at the ceiling, dreaming of what's possible. Technology's pushing the boundaries further, and the next decade's going to be wild. The Euclid telescope, launched a couple years back, is mapping billions of galaxies to trace dark matter's fingerprints through lensing and clustering. Meanwhile, the Vera C. Rubin Observatory, set to light up soon, will scan the sky with a 3.2 gigapixel camera, think 1,500 high-def TVs worth of detail, hunting dark matter's subtle bends. And underground, experiments like LZ and Xenon are doubling down, scaling up to catch that elusive WIMP. If they snag it, we'll have a name, a mass, a profile, dark matter's mugshot. If they don't, we'll pivot again, maybe to axions, super-light particles that could flood the cosmos, or sterile neutrinos, ghostly cousins of the ones we know. Each failure's a clue, each step a thrill in this cosmic detective game. Historically, dark matter's story mirrors humanity's quest for truth. Think about the Copernican revolution. Earth wasn't the center, the sun was. So, then Hubble showed our galaxies just one of billions. Dark matter's the next humbling twist. Most of the universe isn't even ours to see. It's like finding out your house is built on someone else's land and they've been there all along. Silent. The Greeks saw the stars as gods. We see them as fusion furnaces. But dark matter reminds us we're still groping in the dark. Pun intended. It's a thread from Zwickie's 1930s grit to Rubin's quiet genius. A saga of stubborn humans chasing the invisible, piece by piece. Psychologically, dark matter's a Rorschach test for our species. Optimists see it as a frontier, proven to us more, to discover, more to conquer. Pessimists feel dwarfed, a speck in a universe that doesn't care. Studies on awe, like those from UC Berkeley, say mysteries like this can shrink our egos but boost our sense of connection. Ever stared at the stars and felt tiny, yet part of something huge? That's dark matter's gift. It humbles us, then lifts us up. It's why we build telescopes, dig detectors, launch probes, not just for answers, but for that rush of being alive in a universe this vast, this strange. Space-wise, dark matter's still rewriting the map. Take galaxy formation. Without it, the Milky Way's spiral arms wouldn't hold, Andromeda wouldn't loom as our future crash partner 4 billion years from now. Even black holes might owe it a nod. Dark matter halos around galaxies could seed those monsters, funneling mass to their cores. And the universe's endgame? Dark matter slows the expansion, but dark energy, another mystery, speeds it up. If dark matter's heavier or lighter than we think, it could tip that balance, deciding if we crunch, rip, or fade into cold eternity. It's not just background noise, it's a player in the cosmic finale. Let's wrap with a fact that ties it all together. Dark matter might be why we're here, to ponder it. The early universe was a tightrope. Too much matter, it collapses. Too little, it spreads thin. No galaxies, no us. Dark matter hit the sweet spot, clumping just enough for stars to ignite, planets to form, life to spark. It's the unsung hero of existence, a shadow we can't thank but can't ignore. As of February 22, 2025, we're still chasing it. Telescopes piercing the void, detectors humming underground, minds racing with what-ifs. Dark matter's not just a fact, it's a story. Science's grit, history's echoes, nature's depths, space's grandeur, tech's edge, and our own restless soul, all rolled into one. So next time you look up, squint past the stars, something's out there, unseen, holding it all together, and we're closer than ever to meeting it. Stick around, hit that like button, and let's keep exploring the wild unknown together. See you in the next one.